What's up, guys? This is Mr. Bond. Today we're going to run through derivatives using chain rule. So chain rule is basically the idea that we are finding the derivative of a composition of functions. A composition of functions is like f of g of x when you did your fogging and Goffing back in pre-calculus, where you have a function on the inside and a function on the outside. And using chain rule is really very visual. It's really all about being able to see the inside part and the outside part, and reading your functions. So when you're finding the derivative of a composition of functions, the way that we use chain rule is we find the derivative of the outer function, we leave the inner function alone, and then we multiply that by the derivative of the inner function. I think chain rule can be very intimidating, especially with this kind of notation, but let's look at some examples and let's make it a little better. So let's take a look at this first example. We have 4x plus 3 all raised to the third power. This is a chain rule problem because the outer part is something is getting raised to the third power, and the inner part is 4x plus 3. So in order to evaluate the derivative, we need to first deal with the green part, which is the outer function. So the outer function is something getting raised to the third power. Well, we know that we drop the 3 down and decrease the power by 1 using power rule. The inside stays the same, 4x plus 3. And then we multiply by the derivative of the inside, which is just 4. And now I can clean it up a little bit, multiply my constants together. You really don't have to simplify too much using chain rule. Just simplify your constants, keep it simple. And here's our first derivative using chain rule. Not too bad. Pause the video, try these two problems on your own, and then unpause when you're ready to see the solutions. All right, so let's take a look at our answers here. For the first one, the outer part is something getting raised to the 10th power. I'm going to bring the 10 down, decrease the power by 1, leave the inside the same. The inside part is my 3x squared plus 7x. Then I multiply by the derivative of 3x squared plus 7x. Boom, done, chain rule, piece of cake. On the other problem, I want to first re-express the square root of 10x plus 1 using a rational exponent. Note that I still maintain my y equals because I did not start finding the derivative until the third line. When I do find the derivative, I note that the outer part of my function is something is getting raised to the 1/2 power. So I bring the 1/2 down, I decrease the power by 1, I leave the inside alone for that step, but then I multiply by the derivative of the inside. And then I just cleaned it up a little bit, multiplied the 10 by the half. Try these two problems. There's a slight difference between them. Makes a big difference with chain rule. You can pause the video and unpause when you're ready to see the solutions. All right, so on number 3, that cube applies to the entire trig function after you're evaluating your angle. So that makes it the outer part of the function, whereas the sine x is the inner part of your function. On number 4, when you see that cube written directly after the angle, that means that only the angle is getting cubed, and then you are evaluating the trig function. So the trig function on number 4 is the outer part. So evaluating number 3, outer, then inner, I drop my 3 down, I keep the sign the same, the derivative of sine is cosine. So I multiply by cosine of x afterwards. On number 4, the outer part is the sine function. Derivative of sine is cosine. I leave the x cubed alone, then multiply by the derivative of x cubed, which is 3x squared. And I just chose to put the 3x squared out front. So make sure you pay attention to the subtle difference with trig functions. It depends on where you see that exponent written. Either the entire trig function is getting raised to a power, or just the angle is getting raised to a power. Another one for you. This is a fun one because this one involves a combination of rules. So pay very, very close attention to what rules you need to use. Pause the video when you're ready for the solutions, unpause. All right, so let's take a look at this thing. The outer part, clearly you are raising something to the third power. The inner part is a little less nice. The inner part, we have to use quotient rule. So we'll come back to that in a second. Let me take note of that, though. I have to apply quotient rule when I do the derivative of the inside part. Okay, but we start with the outside part, and that's nice. Something raised to the third power. So all I have to do to start is bring down my 3, leave the inside alone, and square it. But now I need to do the derivative of that inside part, And in order to do that, I'm applying quotient rule. A prime b minus b prime a all over b squared. So that's what that giant fractional value is. That's just me applying quotient rule to the inside. And then you guys can see that I just kind of cleaned this one up a little bit. It does simplify pretty nicely because you end up with 4 different 3t squared plus 2's in the denominator, which is kind of nice. All right, try this one. Again, pay attention to which rules you need to apply and pay attention to the order by which you need to apply those rules. Pause and unpause when you're ready. All right, so we are applying product rule here. I first re-expressed my function to get rid of the square root. The a term is the x squared, the b term is the x squared plus 1 raised to the 1/2. So a quick reminder about product rule, just to review. Product rule is a prime b plus, let me make sure I color code this, plus b prime a. So I'm applying that derivative rule first and foremost when I'm going through this process. So my 2x at the beginning, that's my a prime. I rewrite my b term next to that, plus b prime is that whole thing, all 3 of those values multiplied together, and then I have the a at the end. Okay, so what makes this problem tricky is the b prime, and specifically remembering that 2x. Okay, because when you're evaluating that b prime, looking at the b term, it's a chain rule problem. The outer part is the 1/2, the inner part is the x squared plus 1. So just when you're doing that b prime part, you're bringing the 1/2 down, you're decreasing the power by 1, leave the inside alone, times the derivative of the inside. So you have to remember to do all of that in that process when you're doing the b prime part of your product rule. But other than that, it cleans up slightly nicely, and then you're done. All right, one more. Let's end on a high note. This is a pretty nice one to finish on. All right, so I brought down my 21 because I recognize that the outer part of this function is something's getting raised to the 21st power. Decrease that power by 1, leave the inside alone, and then I just multiply by the derivative of the inside, which is much, much nicer than thinking about trying to expand that tangent of x plus 10x 21 times. So that's the beauty of chain rule. Thank you guys for following along.